So hello everyone. So today we're gonna discuss about the LeetCode contest that happened today itself, weekly contest 276. So let's discuss the solution. So today I managed to solve three problems. So let's discuss the solution for these three problems. And the fourth one, once I upsolve it, I will definitely upload in my channel. So let's start with the first one. So here in this question what we were given is we were given a string s, and then we were supposed to create a substring of that string having a size equals to k. Means we have to divide that entire string into a group such that each group will have a length equals to k. So we would be able to do this only if the length of the string given to us is actually multiple of k. So if it is not, then we are also given a fill string which actually contains a single character that can be used to fill up the remaining members. Like for an example, if you see the second example, here the length of the string is 1 2 3 4 5 6 7 8 9 10, which is not a multiple of 3. 10 is not a multiple of 3, so we will be able to create three groups, but for the fourth group we will not be able to create a member of size 3 because there would be only one member j. So in that case we can use this fill string to fill up those empty spaces, and this fill string will always contain a single character. Okay, so here is the constraint. Length will be at max 100, k will be at max 100. So what we did is we created an answer list which will actually store all the result which we can finally return. And now we iterated over the string and having a subset of having an offset of k. So here what we are doing is we are actually taking us this is called slicing in Python. Here what we are doing is, suppose we started from 0, right, and we wanted to create a substring of size k. So this will be 0 and this will be 0 plus k, means in our case the k is 3. So 0 plus 3 is 3, so only 0 1 and 2 will be considered. So 0 1 2 index will be considered, since the last one is excluded in case of slicing. And then we actually are checking whether the length is equals to k or not. If yes, then we can directly append to our answer. If no, then we need to find out uh, how many spaces are left in the group, like whatever group we have created by this slicing operation, right? So that group will have some members, but those members number of members are not equals to the number of members required, which is specified by the value of k. So what we can do is we can take the difference of k and the uh, length of p, which actually represents a group, and then that many spaces will be actually left to be filled up. So we can actually concatenate those many character, and then we can concatenate it to our final string. uh, and once it is done, we can append it to our answer and return the answer. So it's something like this. In the second example, suppose j will be there, so length of j will be 1, since there is only one member j in our string for the last group. And then what we can do is we subtract the difference 3 minus length of j, and it will give us 2. So we have to take this x twice and concatenate it with our j. So that's what we are doing over here, and then append it to our final answer and return the answer. So speaking about the time complexity, the time complexity will be, since we are running the loop for all indexes of the string starting from 0 to length of s, so it will be order of n, and each time we are taking a slice which has a size of k, so it will be order of k, so overall time complexity will be order of n into k. So that was the first problem and it was quite easy. So let's come to the second problem. The second problem is minimum moves to reach target score. Now here this is the interesting problem. Here what you are given is, you were given an integer having a value as 1 initially, and now you want to reach some target value by performing two kind of operation: increment operation and double operation. Okay, so there is a certain limitation in performing double operation, but increment operation can be performed any number of times. So double operation can be performed at the max double number of times, and we need to find out the minimum number of moves needed to reach target starting with 1. So what we can do here is consider the first example. The first example itself says the target value is 5, but we can't use any double operation because the maximum number of double operation that can be used here is 0, so we can't use any double operation. So we simply have to keep using incremental operation, which is nothing but increment 1 at a time. So currently our initial value is 1, and we need to reach this target 5. So difference between 5 and 1 is 4, that means 4 times the increment operation will be used, so that's why the output is 4. But if you see in the second example, we can actually use 3 times the incremental operation, so the overall answer will go to 4. Then we can double that 4 to reach 8, so overall steps will be 3 plus 1 4, and now increment it and get it to 9, so it will be 5. So then after doing increment operation, we have done double operation, that means double the value 9 so that we can reach 18. So this is the sixth step, and the seventh step would be increment the value 18 by 1 by performing increment operation, that will be the step 7. So for this scenario, the minimum number of steps that are required to reach target 19 from 1 will be 7. Similarly, the third example has been given. Okay, so now what we can do is, instead of going 1 to target, what we can actually do is, we can do a reverse logic here. uh, we can actually start with the target value and try to reach 1. So for that, what we gonna do is, we gonna do have a change in two things. The first thing would be to replace the increment operation with the decrement operation. So that would be the first scenario, and the second scenario is to replace the double operation with the division operation, since we are going with the backward logic. So double will get replaced with the half, and increment will be replaced with the decrement. So that way, the first intuition I had used. So initially the steps will be 0, since we have not taken any kind of steps yet. But the problem with this logic would be that if you reach any number which is actually an odd number, so in that case, even if you have a choice of taking a double operation, you still can't take it because the number itself is an odd number. And if you do perform the division operation, then there is a data loss in that, and because of which you will get a wrong answer. Like for an example, suppose in the second example itself, if there is 19, and you know that you still have a choice of taking two division operation. So you divide 19 by 2 to reach 9, and then you divide 9 by 2 to reach 4. So two steps has been done, and this double operation has been reduced to 0. So now you can't use any division operation anymore. So now once you reach 4, now you're, since you were supposed to reach 1, from 4 you can do 3 decrement operation. So 4 minus 3 will be 1. So in that way you have reached 1 from 19 using 5 steps. But here if you see, the answer is 7, and the reason why you have gone to steps 5 is because you have performed double operation on the odd number, and because of which there was a data loss, and thus you have come up with fewer number of steps than the required steps, which is actually wrong. So instead of doing that, what you could do is you can check if the target value is odd or even. If it is even, then there is no problem, we can actually use our division operation. But if it is odd, then increment the value of step as 1, since we are now going to perform some operation which is decrement operation. So that's why incremented the steps as 1 from 0. And the reason why we are first performing division operation greedily is because if we are able to reduce our given target to a smaller form and then perform the decremental operation, then we are very much close to our target, and we would be able to reach our target in fewer number of steps, right? But if we perform operation instead of division operation at the very first level itself, then we won't be able to achieve our target with fewer steps. So that's the whole idea here. So I ran a loop here. The loop actually checks whether do we still have the division operation left with us, and whether the target value is still greater than 1, and if yes, then we can do target equals to target by 2. This is integer division, and then increment the steps value since we have performed 1 steps here. Decrement the division operation since we have already used 1 division operation here. Now here comes the one more tricky part here. Since we have performed the division operation here, even though it was an even number, there might be a case that after performing the division operation we would have gone to an odd number. And now, since we already discussed what would be the problem of applying division operation on odd number, so we need to take care of that here. Like suppose 10 was the even number and if we perform division operation over here, then after performing that operation we have received a value 5, which is actually an odd number. So if we receive something like this, like odd number, then what we have to do, perform one extra operation here. So extra step has been added, and that one extra step would be the decrement operation. So switch on from the odd number to the even number so that we can continue our division operation further. Okay, so once all this double operation and target value double operation has been performed, or let's say once the target value is no more greater than 1, we can actually end our loop here itself. And then after ending our loop, we can check whether we have reached our target or not. If yes, then return the step, or else suppose we didn't reach our target, then what we gonna do? Suppose for an example, in the second example itself, we actually, the first step would be the decremented by 1 since it's an odd number. So that's the first step. Second step would be So first step would be decrement it by 1, so we will reach 18. Second step would be to divide it so that we can reach to a lowest number. So this is the second step. Third step, again we have reached to an odd number, so decrement it by 1 so that we can turn it to an even number, 8. And then again the fourth step would be to divide this number by 2 to make it divide it by 2 to make it as 4. So if you see, we have used one division operation here and one division operation here. Okay, so there were two division operation allowed. If you see, max doubles equals to 2, so 2 has been used, and because of which our loop will end over here, right? Since we have added this condition, now we have reached 4 here, right? And number of steps taken to reach 4 is 4. So now from 4 to 1 we can only perform one operation, and that is decrement operation. So the 4 to 1, the number of steps required will be nothing but equals to their difference. So their difference will be 4 minus 1. So that's what we have done here, right? Whatever is the target value after running this loop minus 1, that would be the additional number of steps that we are supposed to perform, and then whatever steps we have performed till now, the addition of all these two entities will give us the final result. So that's how we have solved the second problem. And speaking about the time complexity, it will be nothing but at the max it will be order of log of n to the base 2, since at each step we are dividing it by 2. So this will be like if there is 8, then 4, then 2, then so it will be order of log of n to the base 2 comma, it would be the minimum of this two one, means which condition will fail here. So either this one will fail or this one will fail, right? So it would be the minimum of these two. And space complexity will be order of 1, since we are not using any extra space here other than the step variable, right? So this was the second one. Now let's move to the third problem here. Let me check it is getting recorded or not. Yes. Oh god. So let's move to the third problem. So third problem is also an interesting one. Here we were given a 0 index 2D integer array question, and where questions of I is equals to points of I comma brain power I, right? So here we are asked that the array describes the question of an exam where you have to process the question in order starting from 0 and make the decision whether to solve or skip each question. Solving question I will earn you points, but you will be unable to solve each of the next brain power questions. If you skip question I, you get to make decision on the next question. Okay, so actually what they are saying here is, suppose we are given a list of questions. This is question 1, question 2, question 3, question 4. Okay, suppose if we try solving question 1 first, then what we achieve here? We achieve 3 points, right? But the problem is, if we take question 1 and solve it, we do achieve 3 points, but we won't be able to solve the next 2 questions, which are this. So that's what they are saying here. So now what we are supposed to find now here is, we have to solve questions in such a way that we are able to collect maximum points from it. So that's what they are asking in this question. So the length of the question is 10 raised to 5. The question I dot length will be 2, means obviously the first one will represent the point that we can achieve by solving that question, and the second one, second parameter says that how many number of questions we won't be able to take after this. So this, after reading this problem, what actually exactly comes in our mind? The first thing actually that comes in our mind is, we need to consider those questions in such a way that it yields out maximum points for us. So what we can actually do here, suppose if we consider this question, let's start from right to left. Suppose if we consider the last one, if we solve it, we will be achieving 2 points from here, right? So how many questions are there? 1, 2, 3, 4, right? So here we will be achieving 2 points, and we won't be, as per the condition mentioned, we won't be able to solve the next 5 questions. But this, since this one is the last one, so it doesn't matter actually. So then what we can do is, we can actually move to the left here. So 4 comma 4. So if we solve that question, what we gonna get? We gonna have, we gonna have 4 maximum points we can achieve by solving that question will be 4, uh, and we won't be able to solve the next 4 questions. So that's what the solving third question would it be, would like. And if we solve the second question, what's the maximum score I can achieve? So if I solve the second question, I won't be able to solve the second one and the third one. So maximum point that could be achieved is 4 only, right? Since that would be the only question I would be solving, since the next 3 questions won't be available for us after solving that one as per the condition. But what if I solve the first one? So if we solve the first one, then the maximum point we gonna get is 3, and we won't be able to solve the next 2 questions, which is 4 comma 3 and 4 comma 4. So the very next question that we could solve is 2 comma 5. So 3 plus 2 will be 5, isn't it? So the main crux of this question would be like, suppose here if we solve this question, now these 2 questions won't be available for us, but the question starting from here would be available for us, right? As per this test case, there is only one question here, but what if there would have been other questions, like after 2 comma 5 there would have been 6 comma 2, then 7 comma 8, like that. So what would have been our answer for this case then? In that case, we would have taken the maximum of all this, the maximum points that we could have achieved from all this, and then we would have added here, right? So that would have given us the maximum points that could be earned. If we go to the next one, if you see here, the maximum point we can get is 5, the maximum point we can get is 4, the maximum point we can get is 3, but the maximum point we can get here is 2. But after solving 2, these two questions won't be available for us, but this one would be available here. So we can actually consider the current index, which would be 0, 1. So consider the current index. So it's like current index plus this would be like question, second parameter, right? The second parameter we have to consider, question of I, question of current index comma 1, right? Means we can't solve these two questions from here. So if this is 1, then 1 plus 2 is 3. So 0, 1, 2, 3. So till 3 we can't solve. So after 3 only we can solve questions. So we can do something like this. Sorry, yeah, something like this. And then we can actually take the maximum from here. Current index plus question index plus 1, then current index plus question of index 2, then current index plus question of index plus 3, like that. Means from all among those available questions, select the maximum one which is giving you the maximum result. Since we are going from right to left, we can actually simultaneously store the maximum in a special in a separate data structure, and then we can actually uh, solve it. So as you can see, if you are still not clear, we can actually walk through this code and understand it in much better way. So here I have initialized two arrays. One is answer and the other one is max, which will store the max values. Okay, so now p is 0. The final maximum output that we gonna get will be stored in p. So now what we will do is the maximum points that we can achieve by solving the last question will be equals to the last question's maximum point itself, right? So this is the base condition we have initialized here. Then we are doing the uh, iteration from right to left, and then what we're gonna do is, if we solve this jth question, then how many questions we won't be able to solve? It would be questions of j 1 plus 1, as we discussed here, right? Current index plus question of current index, and in that also the first parameter, because the first parameter shows us how many questions we won't be able to take after solving the current question, plus 1. From there itself we can start solving the next question, like that. Okay, so if that is less than the length of the question itself, and why we are taking less than length of the questions, as you saw here, right? If we solve the last question here, the current index will be 0, 1, 2, 3. So this is the third question. If we solve the third question, how many questions now we won't be able to take after solving this? So the current index uh, plus 5. So 3 plus 5, 8 plus 1, 9. So from ninth itself we would be able to solve the remaining question, but there are no remaining questions after this, right? So that's why we are ensuring that we are not crossing our boundary. So that's the boundary case here. And if that's the case, then what we can do is we can simply add this uh, points after solving the jth question, and the maximum of what we have achieved, like as we discussed here, right? It would be max of current index plus 1 comma current index plus 2 comma current index plus 3 and so on, right? That would be the maximum of all these things. So for doing all these things, we are actually storing it at one particular place, which will be nothing but maxer. And then we are storing the result here, and in else condition, suppose if this fails, then we can directly take that question as itself, and whatever points we will get after solving that will be our answer. Okay. And this answer of j basically will represent the maximum, uh, maximum point that we have achieved. And after doing this, we can actually maximize our answer by uh, taking the max of whatever current value would be current maximum, and the maximum that we have found from here. So that would be our overall maximum, and then we are updating our maxer array by using that value. And then after the end of this loop, we have actually returned the maximum points that we were able to find. So basically this is a kind of dynamic programming question. uh, I hope you would have understood the solution of this question. Now speaking about the time complexity, it will be order of n time complexity. Space complexity will be again order of n. So that's how we have done the first three questions. So if you like the video, then please hit subscribe button, please like the video, share among your peers, so that we can do this on a daily, weekly and bi-weekly contest, as well as the daily challenge problems. And if you want the solutions, just mention in the comment section. I will put the link of all these solutions that has been explained in the github, and will share in the description. But you should try it first by yourself before looking into the solution. So that's it for the day. Thank you. Bye bye.